In this video, we're going to see how we can do a hypothesis test for two population proportions using Excel. This question says, a study was conducted to determine the proportion of people who dream in black and white instead of color. Among 310 people over the age of 55, 62 dream in black and white. And among 304 people under the age of 25, 15 dream in black and white. Use a 0.01 significance level to test the claim that the proportion of people over 55 who dream in black and white is greater than the proportion for those under 25. Complete parts A through C below. So we have two groups of people here. We have people over the age of 55 and we have people under the age of 25. And we're trying to compare them to see if the proportion of people in those two groups is different, if one is greater than the other, as far as how many of them dream in black and white as opposed to color. So the first thing we need to do is figure out what our null and alternative hypotheses are going to be. They tell us here in the question that we want the first sample to be the sample of people over 55 and the second sample to be the sample of people under age 25. So when we see a P1, we know that means the proportion from the over 55 group. And when we see a P2, we know that means the proportion from the under 25 group. So when we're figuring out what our claim is and coming up with our H0 and H1, we have to look for the word claim or something that implies the word claim in our question. So this question said, test the claim that the proportion of people over 55, remember that was P1, who dream in black and white, is greater than the proportion of those under 25. That was P2. So here the claim is that P1 is greater than P2. The proportion over 55, P1, is greater than the proportion of those under 25, P2. What's important to remember is that in the null hypothesis, we always must have an equal sign, always. So I already know that C and F and E cannot possibly be the right answer here because the statement in the H0, the null hypothesis, is not a straight up equal sign. So it's only going to be A, D, or B here. Taking it a step further, it's going to be A, because this is the one where in the alternative hypothesis it says P1 is greater than P2. So remember, the null hypothesis always has the equal sign in it, and the alternative hypothesis will have a greater than, a less than, or a not equal in it. So now we need to find the test statistic. So in Excel, there is not a straight up way to compute the test statistic, so we're going to have to build it by hand, but it's not so bad. So this is the formula for the test statistic. It looks a little gnarly, but it really isn't bad when we're using Excel. So the things that we need in this test statistic are we need P1 hat, P2 hat, that means the sample proportions from the first group, over 55, and the second group, under 25. And we also need this thing called P bar. That's where we take the two values of the number of people that were successful in whatever criteria we were looking for and add them together in a numerator, and then take the totals from each group and add them in a denominator. So what does all that mean? Let's go ahead and add a few things here. So this is going to be for the over 55 group. So in the over 55 group, we had a total number of people, and we had the people who dreamt in black and white. So going back to our question, the total number of people in that group was 310, and of them, the number that dreamt in black and white was 62. So let's just fill those in. So this was 310, and this was 62. Likewise, let me just copy this, and I'll just change this to under 25. So in this group, we had 304 people, and 15 of them dreamt in black and white. So what was it? 304 and 15. So now P1 hat, That is going to be the proportion of people from the first group that dreamt in black and white. A proportion just means the number of successful people, the people who dreamt in black and white, divided by the total. So we can create our own little formula for that by starting with an equal sign and take the number from the first group who dreamt in black and white, 62, and divide that by the number who the total number of people in that group. And again, as always, we can just click on the cells where those numbers are being stored, and Excel will bring those cells into the formula and know to find the number it's looking for in that cell. So point 2 is the sample proportion for that first group. We can do the same thing for the second group, P2 hat. So P2 hat is going to be the same thing. We start with an equal sign and we take the number of people who dreamt in black and white and we divide that by the total number of people in the group. So 0.049 is the sample proportion for that one. Now we do this thing called P bar, P with a little bar over it. So basically what we're going to do there is we're just going to add together the two numbers, the 15 and the 62, for the people who dreamt in black and white in the numerator of the fraction right here. And in the denominator of the fraction, we're going to add together the two totals. So we can do that again by starting with an equal sign. We're going to put parentheses around the numerator and parentheses around the denominator to make sure Excel is doing the steps with the correct order of operations. So we're going to do x1, which is the 62, plus x2 in the numerator, close the parentheses, divided by, again, open parentheses around the denominator, the total for the first group, plus the total for the second group, close the parentheses, and hit enter. So that's our P bar. We also need something called Q bar. Well, Q bar is easy. Q bar is just 1 minus P bar. So we always start with an equal sign, and we're going to do 1 minus P bar was this value right here. So now we have our Q bar. Now that we have all these pieces, we're ready to go ahead and make our test statistic formula, which is going to be this guy right here. So for the test statistic, we are going to start with an equal sign. And the first thing we're going to do in the numerator is do P1 hat minus P2 hat. We're going to put parentheses around that to make sure the order of operations is done in the correct way. So P1 hat was right here, minus P2 hat was right here, and close the parentheses. Now in the formula in the book, it tells you to subtract another quantity, which is P1 minus P2. P1 minus P2 would mean the two proportions from the population. But remember, in our H0, our null hypothesis, we were saying that P1 was equal to P2. So if P1 is equal to P2 and I subtract one from the other, that means I would get a quantity of 0 here. And they even make a note that P1 minus P2 is 0 assumed in the null hypothesis. So to be honest with you, I don't know why this is necessary to print in the book to show you here, because we're always going to be assuming that this is 0. So we just leave it off. Anything subtracting 0 is just itself. So that's all we need for the numerator. Now we need to do the denominator. So here we're going to divide by the square root of all of this. Now a square root we enter by going SQRT and open a set of parentheses. Now we need to put in these two fractions and add them together. So I'm going to open another set of parentheses to put in my first fraction. The first fraction is P bar times Q bar divided by N1. N1 is the sample size for the first group. So P bar is here times Q bar is here, divided by N1, meaning the size, the total from the first group, right here. Close the parentheses. So that's the first fraction, this guy right here. Now we're going to add plus this second fraction. So we open parentheses, and again it's going to be P bar times Q bar divided by N2, which is the total from the second group. Close the parentheses on that fraction. Now close the parentheses to close off the square root that we started in the first place, and that's it. We can hit enter. So this right here is going to be our test statistic, 5.635, etc., etc. So let's look at the question and see how many decimal places they wanted us to round to. This says to round to 2 decimal places. So as always, this is way more than 2 decimal places. So if we go to the Home tab and come over here, this will let us increase or decrease the number of decimal places that's being shown. So we can decrease this down till we just have 2 numbers after the decimal point. 5.64 is going to be the test statistic here. So now we need to find the p-value. To find the p-value, it depends on whether we have a left-tailed, a right-tailed, or a two-tailed test. If we have a left-tailed test, we're going to use the norm dist function. If we have a right-tailed test, we're going to do 1 minus the norm dist function. That's because the norm dist function in Excel is always giving us area to the left. So if we want a right-tailed value, we need to just take the complement of the area to the left. The complement of the area to the left is the area to the right. And if we have a two-tailed test, we would do one of these two formulas depending on if our test statistic was negative or positive. So here, if we remember back, this was our alternative hypothesis that P1 was greater than P2. So that means we're going to have a right-tailed test. You can look at the inequality here and kind of think of it like it's an arrow. This sort of looks like it's an arrow pointing to the right. So that indicates to you that it's going to be a right-tailed test. So to find our p-value, we're going to start with an equal sign. Remember, for a right-tailed test, we do 1 minus the norm dist function. So 1 minus. The norm dist function is under formulas, more functions, statistical, and we go all the way down to the end section. Norm dist is right here. So when it says x right here, the value you want for the x is going to be the test statistic. So we're going to click on the test statistic right here. This is a z value, so that means the mean is 0, and the standard deviation is 1. And for cumulative, we're going to type true because we do want to have a cumulative area all the way into that tail. So we click OK. So this is the p-value, very small number. Look at all these zeros here after the decimal point. And the question wanted 3 decimal places. So again, we can go to the Home tab and come over here and reduce this down to 3 decimal places. So we don't really need to do this. I can see pretty clearly this is going to be 0. So we come over here and put in 0.000. So now we need to make a conclusion about our original claim based on the numbers we just got. So the way we make our conclusion is we're going to compare the p-value to the significance level. In this case, the p-value was 0.000, so it's 0 basically. And remember, the significance level they told us to use is 0.01. So the rule is if the p-value is less than the significance level, you are going to reject H0. If the p-value is more than the significance level, then you will fail to reject H0. This is the null hypothesis. So in this case, the p-value is basically 0 rounded, and that's definitely less than 0.01. So since the p-value is less than the significance level here, we would reject H0. So here it says the p-value is less than the significance level, so we're going to reject the null hypothesis. Now looking back up here, remember the null hypothesis said that the two proportions from the two groups were equal. So that means that the people who are over 55 dreamt in black and white at the same rate as the people who are under 25. But we just decided to reject that statement. So when I reject a statement, I like to cross it out just to have a visual to myself that I don't like this statement. I want to reject it. Well, if I reject that statement, then I don't have any alternative left except for the statement in the alternative hypothesis, which said that the proportion from the first group, over 55, is indeed greater than the proportion from the second group, under 25. And remember, originally that was our claim. So by rejecting the null hypothesis, we have found support for our claim. So we would say there is sufficient evidence to support the claim that the proportion of people over 55 who dream in black and white is greater than the proportion for those under 25. Now they want us to test the same claim, but this time by constructing a confidence interval. So we need to do a confidence interval similar to what we did in the past for the difference between the two different population proportions. So in Excel, same thing, we can go ahead and build this confidence interval, and this is the formula we're going to use. P1 hat minus P2 hat minus E, that's the margin of error, which is computed with this formula. That's the lower limit. And the upper limit is P1 hat minus P2 hat plus the margin of error. So let's go ahead and build all those different components. So first, let's do P1 hat minus P2 hat. So remember, we already found P1 hat and we already found P2 hat. So we can start an equal sign here. P1 hat was right here, so we can click on it, minus P2 hat was right here. So we can click on that and hit enter. So now we have a value for P1 hat minus P2 hat. Next, we need the margin of error. To find the margin of error, we need a few things for this formula. We need the z alpha over 2. This is similar to what we did when we did confidence intervals. We need P1 hat, which we already have, Q1 hat, which we already have, N1, which we already have, P2 hat, Q2 hat, and N2 hat, which we already have. So the only thing here that we don't have is the z alpha over 2. So let's go ahead and find the z alpha over 2. Remember, this is called the critical value. So for the z alpha over 2, well, let's start by not labeling like that. Let's start with our alpha. So the alpha here is going to be, let's look back. We want a 98% confidence interval here. So that means that the alpha is 1 minus 0.98. So starting with an equal sign, 1 minus 0.98. Remember, for a confidence interval, the alpha is always 1 minus the confidence level as a decimal. But we weren't looking at alpha here, we were looking at z of alpha divided by 2. So right here we can say alpha divided by 2, and that's very easy. We start with an equal sign and just click on the alpha and divide it by 2 and hit enter, and that's it. So now the critical value, is going to be a formula. So if we go up to the formulas, more functions, statistical, and we go to the norm_in function, norm.inv. The probability here is going to be 1 minus alpha over 2. And since this is a z-score, the mean is 0 and the standard deviation is 1. So we say OK. So now we have the critical value, the z alpha over 2, which means we're ready to find the margin of error by just building this formula right here. So we start with an equal sign. The first thing is the z alpha over 2. That's the critical value. So we just click on this. That's going to be times the square root, SQRT, of, starting with the open parentheses, those two fractions added together. So I'm going to open another set of parentheses to put in that first fraction. So that's P1 hat, which is this, times. Now we didn't actually state out here in our numbers on this side what Q1 hat is, but remember, Q1 hat is just 1 minus P1 hat. So we can just put that in just like that right here. Parentheses, 1 minus P1 hat close the parentheses, divided by N1, that means the sample size from the first group, that was this one right here. We can close the parentheses, and now we've done that first fraction, this whole first fraction here. Now we can add plus this second fraction in the same way. Parentheses, P2 hat times, parentheses, 1 minus P2 hat, that's the Q2 hat, close the parentheses, divided by N2, which is the sample size from the second group. Close the parentheses to finish that fraction. Close the parentheses to finish the square root. Enter. So there's our margin of error. And now to do the confidence interval, the lower limit is this guy right here, lower limit, and that's going to be P1 hat minus P2 hat, which was this number, minus E. So minus, this was E right here. So that's our lower limit. Upper limit, same thing, equals P1 hat minus P2 hat, which was this, plus E, plus E. Enter. Going back to the question, this said to round to 3 decimal places. So if I highlight these two guys and go to home, and this button, I can take this to 3 decimal places. So the lower limit is 0.090. So 0.090. 0.090, and the upper limit is 0.211, 0.211. So now we need to make a conclusion based on these results. So as a note, the results you get from your hypothesis test regarding whether you support the claim or not, it should be the same results that you get from your confidence interval. If you feel like you're getting a different conclusion with your hypothesis test versus with your confidence interval and you didn't change anything, then something went wrong. So what we're looking for here is whether or not the value of 0 is contained in this interval. In this case, it's not. The lower end of the interval is 0.09, which is a positive number, and the upper limit is 0.211, which is also a positive number. So if I'm going from a positive number to a positive number, then 0 is not in the middle of these two. What does that mean? That means that the difference here of P1 minus P2, meaning the difference in the proportions from the two groups, we don't expect that that can be 0. If we don't expect that those can be 0, then it means that those two things cannot be equal to one another. The only way I could take a number and subtract it from another number and get 0 is if the two numbers were the same to begin with. So having 0 as a value between the two confidence limits is an indication that these two items might have been the same. In this case, that's not what we got. We did not get 0 in the confidence interval. So we would say here, because the confidence interval limits do not include 0, it appears that the two proportions are not equal. Because the confidence interval limits include only positive values, right? This number was positive and this number was positive. That means that the P1 was a bigger number than the P2, right? If I take a number and I subtract another number from it and I get something positive, it means that first number was bigger than the second number. So because the confidence interval limits include only positive values, it appears that the proportion of people over 55, remember that was P1, who dream in black and white is greater than the proportion for those under 25. That was P2.